Alright, so this was of course the pseudo frequency analyzer that I tried to basically use a frequency, basically a radio, to determine whether or not I could see 13.56 megahertz. How unfortunately this antenna, and rather this whole setup, just wasn't designed for that kind of work, so it did not work at all. But I learned a lot. I think, you know, learned that I could still identify thermal noise and shot noise, which I thought was kind of interesting and fun. Anyway, so let's go on to this setup over here. This is now, I think, a more realistic setup. So once again, well, got my ring on it. Anyway, so here we've got, if you will, the source. So this is a classic idea of just, you know, a Beer's Law experiment where we have our light source sending out radio frequency of the specified frequency, 13.5 megahertz. It's always on. We'll see that in a second. By the way, and this is a PCSC contactless NFC USB dongle, flat rather, that's what they're called. The ACR 122, I guess this is the most common one. It's the cheapest, most abundant, crappiest one, but it's everywhere, so everyone's got one, right? So it's the best then. Alright, so there's that, plugged in to my Mac, powered on. Voila. We've got, unfortunately, here we go, brilliant loop, I guess. I guess it's of the same size as a theoretical ring. I'm just trying to simulate a ring without grabbing any wire. I just don't have any on me right now, but I had a bunch of binder clips, and they produced a pseudo kind of looking, you know, ringish circle there, so that'll be good. Now I've got my scope, which I was fortunate enough to find a scope. Let me zoom in and whatnot on the magic of scopes. Here we go. It's hard to see actually. It looks like there's a beat. No, there you go. It's much better. You can now see it much. Yeah, it looks really crisp. I could have calibrated. There we go. I could have calibrated, but it doesn't matter. It's just an experiment just to see whether or not it works. I'm dialed in on channel 1, 0.2 microsecond per division. So this gets me within the range of the tens of megahertz. So we'll see what. We'll see whether or not this can be seen on the scope. Oops, God, my ring again. Okay, here we go. So, whoops, I got this. So I'm going to put these on top of one another. Let me just zoom out so you can see a little bit. Oops. Not going to win any design awards for this video, so bring it on, and we see that sure enough you can see on the scope. So let's zoom in on my prep so you can say, oh, he's doing it right or not. Okay, let me zoom out. Alright, so here's the setup once again. Got the probe, I have the oscilloscope on. Oops, that's not what I wanted to show. I've got the other camera controlling it. Let me hit record. So that's being recorded now. I'm going to be looking at this for 2 centimeters. And as we get in, we can see here's the 2 centimeter mark, and if I go further out, it of course is too far away. If I get in very close, it goes off scale. So I think 2 centimeters is pretty good, so I'm going to keep it there. And, righty, I'll go reach. Okay, I moved that around while I was reaching, but let's go back. Here we go. Let me recalibrate that. 2 centimeters, 2 centimeters. 2 centimeters. All right. So we've got the following on the scope. I'm going to put something that should not be radio frequency transparent. This case is RFID shielding. I'm going to put it in here, and we see that we now have dropped the signal. I'm now going to move it out of the way and bring it back. I'm sure there's a lot of double D's out there that are laughing at me, but there you go. Proof of concept using a regular old scope, very simple probe, and a binder clip, and some thinking in terms of analytical chemistry. So, proof positive, this works.